We are going to look at our practice final together. This is the last thing we'll do in here. So once you finish your practice final, once you take your final, you have finished Algebra 1. Very exciting. So let me get my pens out and we're going to get started on this together. On your first page, we have 5 math problems. The first 4 are inequalities. We solve these just like we do equations. The only difference is that we're going to graph them. Number 5 is a compound inequality. So let's take a look at number 1. When we are trying to solve an inequality, an equation, whatever it may be, there are a few different operations we need to think about. And I'm going to write a little list up here at the top. We have 2 steps. Our first step is we want to undo or get rid of addition and subtraction. Second is we undo or get rid of multiplication and division. So in number 1, what would I do to solve this? Yes, we're going to subtract 3 to get rid of it. Because remember, the goal is to get n by itself. And if I get rid of plus 3, now it's by itself. So I'm going to do that on both sides. What is 12 minus 3? 9. So I'm going to bring down my n, bring down my, what's this called? Greater than. N is greater than 9. So that's our answer. Now we want to graph it. There's 3 things I'm looking for on your graph. The first thing is I'm looking to see that you wrote a number on this tick mark. So if n is greater than 9, the number we're writing on this tick mark is 9. Okay? Now, what else do I need to do to graph this? Yes, I'm going to circle this tick mark. And are we going to shade it or no? Why should we not shade the circle? Yes. If I have, here's another good note to take. If I have a greater than sign or a less than sign, my circle should be open. If I have greater than or equal to or less than or equal to, my circle will be shaded. So since we have greater than, we leave it open. Now, which direction do I shade the rest of my number line? To the right. Yes, it's greater than. Remember, if I draw an arrow with that symbol, it's pointing this way. So we shade to the right. So I'm looking for the number to be labeled. I'm looking for a circle, whether it's shaded or open. And then I'm looking to see that you've shaded the rest of your number line. Those are the 3 things I'm looking for. Okay. Let's go ahead and look at number 2. Number 2 is where we start needing to worry about the steps. Getting rid of addition and subtraction first, and then multiplication and division. So I have n divided by 4 plus 3 is less than or equal to 15. What should I do first? Yes, let's subtract 3 on each side of my inequality. Okay, my 3's will cancel. And what happens next? 15 minus 3 is 12. Yes, n divided by 4 is less than or equal to 12. Yes. Now I want to get rid of this division. The opposite of division is multiplication. So I'm going to multiply by 4 to cancel it. And I'm going to do the same thing. Good. Over here. So now I have n by itself. I'm going to rewrite this. I didn't give you quite enough room. I have n is less than or equal to 12 times 4 is 48. Good. Yep, 48 goes right here. Yes, circle it, shade it. Perfect. And then we have less than or equal to. If I made it look like an arrow, that arrow points left, so we shade to the left. Perfect. Perfect. Okay. Any questions about either one of those? Okay. Give everybody just a minute to get that written down. Finish that up. Now, when we get to number 3, this is where we're going to need to be really careful. I made sure to write a little note on here. This is only to help you. It says, remember, if you multiply or divide by a negative number, flip the sign. When I say flip the sign, we're referring to the less than, greater than sign. We're going to have to reverse it if we divide by a negative number or multiply by a negative number. So let's look at number 3. Negative 3 times n is less than 24. Oh, alarm bells should be going off. We're dividing by negative 3. So, at the next step, what happens to my sign? We flip it. Yes. Now we have n is not less than, greater than negative 8. Good. That's our answer. So, if you need to make a note, like I'm going to write here, I divided by a negative. I put the note up at the top, but sometimes it sticks in your brain better if you write that note yourself. I'm going to say flip the sign. When divide or multiply by a negative. There. Yes, now we're going to put negative 8 on the tick mark. Circle it, leave it open. Shade to the right. Now it's greater than. My arrow points right. We shade to the right. Okay. So that is number 3. Let's go ahead and look at number 4. Now I have negative 2 times n minus 4 is greater than 16. Yes. Add 4 to both sides. Good. My 4's will cancel. Negative 2 times n. Good. Greater than 20. Alarm bells. We are dividing by negative 2. What needs to happen? Yes. Negative 2's will cancel. I'm bringing this over here. N is less than. We flipped the sign again. Yes. We divided by negative 2. Flip the sign. And 20 divided by negative 2 is negative 10. Perfect. Good. Good. Less than. The arrow points left. We shade to the left. Okay. So before we go to number 5, I'm just going to make sure everybody can see all of this in case there was a part you didn't get written in time. Yes. So why did we add 4 first? Okay, so the reason that we're adding 4 to both sides before dividing by negative 2 is because whenever we're solving an inequality or an equation, we're using the reverse order of operations. And that's why we put this little key up here at the top. First, we always want to get rid of addition and subtraction. Second, we always do multiplication and division. So down here, I have -2 times n, that's multiplication and division, -4, that's the addition and subtraction. So we always want to get rid of any stray numbers before we separate numbers from our variable. Does that make sense? Okay, perfect. Any other questions? Okay. We ready for number 5? Okay. So, number 5, we have a compound inequality. This is the same thing as we've been doing above. It's just now we're solving 2 and we're putting them on the same graph. So, let's start with this one here. -2 times n minus 8 is greater than 12. Yes, let's add 8 to both sides. -2n. Good. 20. Okay, we're dividing by a negative. Yes. We divide by -2. Good. So because we divided by a negative, we end up with n no longer greater than. We flip it. It's less than -10. So that's our first inequality. Now let's not put this on the graph yet because we still need to solve this one. Now I have 10 plus n divided by 3 is greater than or equal to -2. What should I do first? Subtract 10 from both sides. Good. Okay, my 10s should cancel. Good. Perfect. N divided by 3 is greater than or equal to -12. So multiply by 3. Good. Your sign does not change. Now, why am I not going to flip my sign here? Yes. There is a -12 here, but when we say multiply or divide by a negative, we mean if you do it on both sides. Right here, I'm multiplying by +3 on both sides. I did not multiply by -3. So our sign stays greater than. So, yes, n is greater than -36. So, now we need to decide, where do I put each number on my line? Yes, -36 needs to go first. Why does that one go first? Is it bigger? It's actually smaller because technically it's a bigger negative, which does make it a smaller number. So you're right. -36 comes first, and then -10. Good. Circle it. Oops. See ya. And -10. Circle, leave it open. Good. This is an and inequality. And is in the middle. We can also double check that with our signs. I know n is greater than or equal to -36, so I'm shading this way. -10 is less than. So going that way, the arrows point towards each other. We shade in the middle.
I still don't understand why we have the circle open.
On 10?
Yes.
The reason we left the circle open on -10 is because it was just less than. It wasn't less than or equal to. Yes. So anytime there is a line under the sign, we shade it. When there's no line, we leave it open. Okay. Any questions on the first page? Any questions at all? Okay. Can I go to the next page? Okay, let's go ahead and do that. Now we're moving on to linear equations. We're looking at slope and y-intercept. These should be relatively easy. Number 7, this is something we didn't quite get a chance to talk about. So number 7 will be an optional bonus, okay? Just because we didn't get a chance to talk about that, although it won't be hard. I'll still show it to you. Okay. So let's look at number 6. Y equals 4x plus 1. Which number is my slope? The 4, the number next to x. Now, is it 4 or is it 4x? Just 4, or you could also say 4 over 1. Both are correct. Both are correct. Don't include the x, though. That's not correct. What's the y-intercept? 1. Perfect. Okay, now, here is our optional bonus question for number 7. The form that this equation is written in is called standard form, okay? Standard form is ax plus by equals c. So if this is the form the equation is written in, if I asked you what is the value of a, what would that be? 2. Good. What's the value of b? 8. What's c? Perfect, 16. So there's a special formula for finding these. The slope can be found by using negative a over b, that's slope. For y-intercept, we use c over b. So if a is 2, what is negative a? Negative 2. Good. So for slope, I need negative a over b. What's negative a again? 8. B is 8, yes. So negative 2 over b, which is 8. That would be your slope. You could also simplify that to negative 1 over 4. Both are correct. That would be your slope. If my y-intercept is c over b, what's my y-intercept? It'll be 16 over 8. What does that simplify to? 16 divided by 8. 2. Okay. So again, this is optional. It is a bonus. We did not get a chance to cover it this term because quite honestly, I forgot about it. So we're doing it now. You've been exposed to it. It exists. It won't go against your grade if you don't get it right because that's on me. So any questions about that? You went faster than our writing, so I didn't really even catch it because I was writing. Okay. So it's negative a over b for our slope. Our a comes from here. The a is 2, b is 8, c is 16. It's just in letter order that the equation is written. So if I want negative a, well, a is 2, so negative a is negative 2. It's just what was in the equation. Your original equation is, yes. Okay, perfect.
Yeah, I was right.
You're okay. You're okay. All right. Any other questions? Okay. Can we go to number 8, or does anybody still need to see this? Okay. Let's look at number 8. Now we're going to identify the slope and the y-intercept of the graphed line. So for number 8, how am I going to find the slope of this line? What is slope? Rise over run. So I need to count from one point to the next. How far do I rise? How far do I run? So we're always going to go left to right. I'm going to start here. How many spaces will I rise? 4. 1, 2, 3, 4. So that's my rise. And my run, 2. So my slope is 4 over 2. We could also say 2 or 2 over 1, whatever you like. Both are correct. Yeah, y-intercept. Now, this one, I'm going to zoom in real close as much as I can. Hang on. The y-intercept is where does my line touch the y-axis. No, there's not a point here, but this is still where the line is crossing the up and down line, the y-axis. So the y-intercept is just wherever that crosses it, and it crosses at -3. So let me zoom back out. Our y-intercept will just be -3. All right. Now, something good to remember whenever we are counting rise and run and your slope, we need to keep in mind what happens to the sign of our slope, whether it's positive or negative, depending on the direction we go. Another good thing to remember is if my slope tilts upwards like this, it's positive. Now, number 9, is that slope gonna, before we even get the numbers, is that gonna be a positive slope or a negative slope? Negative slope, good. It's because it's tilting down. Let's see, I bet you're right. Let's count. We are going down 1, 2, 3, 4, 5, 6, 7, 8. Yep, -8 because we went down 8 over 2. Good. -8 over 2, what does that equal to? -4. Both are correct. Yes, your y-intercept. 1. We can see this is where I touch the y-axis at 1. Okay. There we go. That's number 8 and number 9. Do we have any questions about this page? Okay, can we go to the next page? Does anyone need more time? Okay. See a few more people still writing. I'll wait a minute. Okay. All right. Going to page 3 now. We have finding the slope using a set of coordinates. Okay? So this is where we're going to use the slope formula. I would recommend writing this on your practice final. And let's refresh our memory. To find slope from 2 points, we're going to use this formula. We have m equals, m is our slope, y1 minus y2, good. Yep, divided by, yes, x1 minus x2. Okay. Now, how should I begin this process? Label. Yes, that is the best first step. Let's label our coordinates. Does x come first in a coordinate or does y come first? X. X comes first. -5 will be x1. Yes, +10 is our x2. So, back to the first coordinate, -2 is y1. Yes, -10 is y2. So we have x1, y1, x2, y2. Now, if you want to continue doing this in the same order where we did x's first, then whenever you plug these into your formula, we're going to start from the bottom. Okay, we're going to take the x's and put them on the bottom, and then we'll put the y's in. Now, you really can do it however is most comfortable for you. So I'm going to leave that up to you. I'm going to go ahead, though, and give myself a set of empty parentheses. So I'm going to write parenthesis minus parenthesis over parenthesis minus parenthesis. Okay. -2 is y1. Yep. -2 and -10. Okay. And then what's x1 and x2? And 10. Good. Okay, so this is the way that your formula should be looking. On top, we have -2 minus -10. On bottom, we have -5 minus 10. Now, what is going to happen on top of our problem? We have -2 minus -10. What does that mean? Yes, yes. If we subtract a negative, it feels unnatural, but really we're adding. Those two minus signs cancel. So really it's -2 plus 10, which is +8. Good. Now I have -5 minus 10. Yes, that is -15. And that would be our answer, 8 over -15. You could also say -8 over 15. Both are correct. Any questions about number 10? Any questions? Okay. Let's talk about 11 and 12. We have graphed equations, yes? Did we graph systems? Uh-huh. That's okay. What's up?
When you found this low.
Yes. For
you put minus. You put 2 minus
minus
10.
Yes.
For the second, you put minus 10.
Yes, because y2 is -10 but x2 is positive 10. So we only need one minus. You see it? Okay. Yes. Okay. All right. So, again, I'm going to ask you guys. We have graphed equations, yes. Have we graphed systems of equations? No. Okay. So, on your final, the thing that I'm going to want to see, because we did not get here, we didn't technically talk about this a whole lot. You're not going to need to know the solution. You're going to pick one and graph it. Pick either one and graph it. Okay? So, don't care which. Pick one to graph. Now, I'm going to graph both of these just to show you both. We don't need this. Okay, so let's start with the top equation. I have y equals negative 1 over 4x plus 5. Where's my starting point? 5, positive 5. That's our y-intercept. So I'm going to go to my graph and find positive 5 right here. Yes, my slope is negative 1 over 4, so I'm going to go down 1 over 4. Oh, man. So down 1 over 1, 2, 3, 4. There's my second point. And what would I do from there? Connect the dots. That's it. Okay. So there is that one. Now, let's also look at the next line, and I'm just going to graph this on the same graph. And technically, this is actually how you solve a system of equations. You just graph them both on the same graph, and you're going to see where they cross. So if you want to try to do the actual system, you can. But because we did not specifically go over this in detail, I'm not going to expect you to have a solution written or anything. So let's look at the second one. I have y equals 7 over 4x minus 3. What would be my starting point? Yes, negative 3 on the y-axis. Yes, up 7 over 4. So 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. Ah, look at that. They share a point. Yes, yes. So now we just connect these dots. See that?
So the solution point would be 4, 4.
Yep, it would. So if you want the solution, I'm not going to expect you to get this correct. This is not going to be a bonus, but it's not going to hurt you if you don't get it right. You don't have to. Our solution is just this coordinate where they cross. So our x value is 4. Our y value is also 4. So the solution would be 4, 4. You do not have to do that, but you can. Would have went up 1? We just got to remember if it's negative, we go down. Yes. Yes. Those negatives will get you. Okay. Any questions about that? All right. I know these take a little bit because there's a lot of points, a lot of lines. We'll go to number 12 here in just a minute and give everybody a second to get this written down. So just remember when you get to this question on the final, don't freak out if you don't know how to do it. It's okay. I didn't teach you in detail. I taught you how to graph a line. I taught you how to find a point, but we just did not go into detail on this specifically. So if you don't get the solution right, I'm not going to take points off your final for it because that's on me. Okay, let's look at number 12 if we're ready. Are we ready? Okay. So again, I'm fine if you just graph one of these. That's okay. Let's start with the top one. I have y equals negative 3x plus 5. Yes, positive 5 would be our starting point. Good. Since my slope is negative 3, it's really negative 3 over 1. So we're going to go down 1, 2, 3 over 1. That's my point. And we'll connect the dots. Okay.
This is for me. Should we be drawing the lines like outside of the graph like that every time?
You don't have
Okay,
to.
that's what
No, I think it's just a force of habit for me. It's always a good idea, especially if,
multiple.
right. Just in case they cross like really far away. You know what I mean? Okay, so we got that. How do I start y equals x plus 1? Good. Start at positive 1. That's my y-intercept. Let's see. Now, my slope is what? What's my slope? 1. Ah, yes. So we go up 1 over 1. Good. So I'm going to go up 1 over 1, and we land on that point that we already had on our previous line. So I'm going to connect those dots. And let's see. If you wanted to label the solution, again, you don't have to. Yes. Yes, perfect. X is 1, Y is 2. Beautiful. Again, you don't have to do that part, but that is the answer if you're curious. Okay. So that's our third page. We just have 4 questions left and then the bonus. I see a few people still writing, so I will give us just a minute. Yes. All right. Can I go to the next page? Anyone still need it? Okay. Let's go ahead to page 4. Okay. Now we have binomials. We just did this. We're going to either use the FOIL method or the box method, and we're going to multiply these pairs of binomials. And from what we talked about last time, it sounds like most of us want to use the FOIL method, so we'll go with that while we're doing our examples. So starting with number 13, what do I need to do first? Good. I'm going to take 4x squared times 3x. And I'm going to take my time writing these out just so that we have a good reference to look back at. So my first step is 4x squared times 3x. And what will that give us? Good. 12x to the third power. Yes. Okay, now we're at the outer terms, the O in FOIL. What do I multiply next? Good. 4x squared times 1. Perfect. That will just be 4x squared. Now we have the inner terms, which are what? 2x times 3x. 2x times 3x. Yes, 2 times 3 is 6. X and x give us x squared. And our last terms? 2x and 1. Perfect. 2x times 1 gives us 2x. Okay, so we have all 4 steps done, but what is the next thing I need to do? Yes. Yes. 4x squared and 6x squared are like terms. So we're going to combine those by adding and get 10x squared. And then we need to write all these out together. So we will have 12x to the third power plus 10x squared plus 2x. And that is our answer. Okay. Okay. Any questions about number 13? Okay, let's go ahead and look at number 14. What should we do first? Good, 4x times 4x. 4x times 4x. 4 times 4 is 16. X and x give us x squared. Now our outer terms, what's that? Good, 4x and 1, which is 4x. Then our inner terms, negative 1 and 4x. Good, that's negative 4x. And last, good, negative 1 times 1 is negative 1. Oh, yes. Thank you. So what's happening here is we have our like terms are 4x minus 4x. That gives us 0. We don't need to write it. These will cancel. So our answer is just 16x squared minus 1. Okay. Oh, sorry. I see 17 questions here. That's not bad. Okay. Let's go ahead and look at 15. So for number 15, my first terms, good, 2x times 2x equals 4x squared. My outer terms,
2x negative 3.
2x negative 3, negative 6x,
Your term is 3, 2x.
3 times 2x, good, positive 6x, 3 times negative 3, negative 9. Perfect. This is another one where our like terms cancel out because negative 6x plus 6x equals 0. They cancel again. So our answer will just be 4x squared minus 9. Okay. So I'll leave that up for just a minute and then we'll look at 16 and 17. So let me just zoom back out a little bit. Okay. This we talked about very briefly, extremely briefly, maybe for 10 minutes one day. We're going to talk about it again. Number 16 and 17 say factor the GCF. That means the greatest common factor of each expression. What does this mean? I'm trying to figure out the biggest number and variable that I can divide this whole thing by. So the first thing I would want to look at is my numbers, 4 and 8. Can I divide those by anything? By 2, by 4, both are correct. If I divide by 2, let's just start there. Let's see what happens. Let's divide by 2. I divide by 2. I'm going to write divide by 2 outside. Okay. Now I'm going to have this 2 out here. And what is 4 divided by 2? 2. I'll bring down my x to the third power. Plus, what's 8 divided by 2? 4x. Can I still divide this by anything? Actually, yes. By 2. Let's divide by 2 again. So I'm going to divide by 2 again. Now, since I divided by 2 at the top, if I divide by 2 again, really what's happening is I divided by 2 twice. That really means we divided by 4 total. So when I go to the next step, I'm writing 4 down here. 2 divided by 2, what is that? 1. So that's gone, and now we just have x to the third power left. Plus 4 divided by 2? 2. X. Okay. Now I cannot divide by a number anymore. Can I divide by x? I can. Yes.
X squared.
Yes. If I divide by x to the third power minus 1 basically, that'll become, I'm going to write the x on the outside now, x to the second power plus the x's here cancel, 2. That's all. That's right. Okay, so what we're trying to see here, whenever I say factor, basically what we've done here is we've gone from this original expression And then we've broken it down into the two things that when I multiply these, I get my original expression again. So watch this. What is 4x times x squared if I distribute?
4x.
Yeah, exactly. I end up with 4x to the third power. Now what if I do the next part of my distribution? 4x times 2? 8x. Yes. So we get right back to where we started. Okay. So that's what we're doing when we factor. We're dividing over and over, essentially. Okay. Now let's peek at number 17. And this one isn't going to take nearly as long because we only have one x. What's a number that I can divide both of these by, 5 and 10? I could do 1. Will that change my numbers though? No. I could do 5. I could do 5, right? I can divide 5 by 5. I can divide 10 by 5. Let's try 5. I'm going to do 5. Divide by 5. So what is 5 divided by 5? It's 1, or that leaves us with x. Leave my 5 out there. Bring down my plus. 10 divided by 5 is 2. And that's all. This would be our answer. Do we see what's going on there? Okay. Now, we can run through a million more of these together. We got the whole week to do that if you want. This is something that is going to be super helpful once we do get to Algebra 2. Just 2 questions. There only was 1 little point each. And if you get them wrong, you can correct them. Remember, we can make corrections until the due date. You have tons of time to make corrections. But we'll talk some more about this here in a minute. If you're freaking out, try to push it to the side for a second. We'll come back to this, okay? We'll come back to it. That's it, other than our bonus. Here's our bonus question. Okay. It's optional. You don't have to do it, but you can. This is just like the bonus on the last quiz we took.
Except for an additional.
Yes, except for now there's an additional term. So I'm going to walk you through this. It's not as scary as it seems. We're just over and over doing distribution. So I'm going to start with this term, 3x to the 4th power. And we're going to ignore the rest that's in that parentheses. Okay, all of that is gone. First, let's do that times the first term over here. 3x to the 4th power times 5x to the 5th power. First of all, what's 3 times 5? 15. So that's our coefficient. Now I have x to the 4th times x to the 5th. X to the 9th. We just add the numbers. Okay, perfect. Now, in distribution, we keep multiplying that same thing, but we go to the next number. So, first, let's do the whole numbers. We've got 3 times negative 3. What's that? Negative 9. And now I have x to the 4th times x to the 2nd. X to the 6th. We're just adding 4 plus 2 is 6. Okay, now we're going to do the last term on that second one. 3x to the 4th times 1. 3x to the 4th. Plus 3x to the 4th. Okay. So we've done that. Now we'll go to the next term, which is 2x to the 3rd power. So we're going to go back again. 2x to the 3rd power times 5x to the 5th. So 10x to the 8th power. Good. We don't have an 8 here yet, so I'm just going to stick it all on here. 10x to the 8th power Okay, now we're going to stay with our 2x to the third, but we're going to multiply it to the next thing in line.
6x squared minus
Yes. So 2 times negative 3, negative 6. X to the third times x to the second, fifth, x to the fifth. Good. And last but not least, we take that again, multiply it by our last term, which is 1. Good. Plus 2x to the third power. Okay. Now, next term, x squared. What am I multiplying it by first? 5x to the fifth power. There's no number in front of x squared, so it'll stay 5, and then x to the 7th power. 2 plus 5 is 7. So I'm going to go below, and I'm going to write 5x to the 7th power. Okay, now I'm going to take x squared times negative 3x squared. What's my number going to be? Negative 3. Good. X squared times x squared, x to the 4th power. And last but not least here, we have x squared times 1, which is x squared. Nice. Okay. One more term to distribute. This is a long one. So now I have negative x. Negative 5x to the... yes. Yes. So negative x times 5x to the 5th power becomes negative 5x to the 6th power, because we have x to the 5th plus another x, or times another x. Okay, now I have negative x times negative 3x squared. Yes, the negatives cancel. We have positive 3x to the 3rd power. And now one last negative x times 1. Negative x. Okay, so we have about 1,000,000 terms here. We're done with them, though. We've done it. What do I still need to do, though? Combine your like terms. So let's start with the biggest number that we have. What is the biggest exponent here? 9. Okay, so 15x to the 9th power. Are there any more 9s? Nope. Okay, so I'm going to bring this down. 15x to the 9th. Now let's go to the next biggest. Is there an 8?
Yes.
There is. I see 10x to the 8th. I'm going to write that down. Plus 10x to the 8th. Is there any other 8s? Nope. Okay, so we're done with that. Is there a 7?
Yes.
There is. 5x to the 7. Is there any other 7s? No. Okay, so we're going to bring that down. 5x to the 7. Is there a 6?
Yes.
There is. Right here. Negative 5x to the 6. There's also negative 9x to the 6. So let's put that down. Negative 9x to the 6th. And I'm going to just put these in parentheses so I don't forget to combine them, because they're both 6s. Okay, so I'm done with my 6s. Is there any 5s?
Yes.
Okay, yeah. Negative 6x to the 5th power. Any more to the 5th power? No. Okay. To the fourth? Oh, yes. What's going to happen to these? These cancel out. I have plus 3x to the fourth. I have minus 3x to the fourth. They cancel. I don't need to write them. Same number, different sign, they cancel. Okay. How about 3? Yeah, 2x to the third power and 3x to the third power. Okay, those will go together. How about the second power? Yep, we got an x squared. And any just regular old x's? Minus x. Okay. So we have our like terms in parentheses. What's negative 5 minus 9? Negative 14. Good. Negative 14x to the 6th power. 2 plus 3. 5x to the 3rd power. Okay, this is a good enough answer. You could leave it like this. Or if you want to be a little bit nicer and neater, we could rewrite it out nicer and neater. I'm going to rewrite it just because 15x to the 9th plus 10x to the 8th plus 5x to the 7th minus 14x to the 6th minus 6x to the 5th plus 5x to the 3rd plus x squared minus x. Ooh! There you go. That's a big one. That's a real big one. I know, right? Yes, Shayna.
Do we have to write, like, should we maybe not necessarily have to, but get in the habit of, like, writing them with the exponents, like,
Descending order? Yes. Yeah. On here, if you don't, I won't, like, not give you your points. Right. But in the future, whenever, depending on what path you decide to take after the Excel Center, if you are doing more math in the future, get used to doing it this way, where we do it in descending order. If not, you know, it won't matter in your life. Okay, so that was the bonus. I also just decided the factoring ones will also be bonus. You're welcome. Because, again, it was just one of those little things that was not really an Algebra 1 thing. I forgot that this was the final from last term, and I forgot last term we ended up doing some other things that we actually didn't need to do, and so I put them on the final, and I forgot about them. So that's on me. Those will be counted as bonus. So if you don't want to do this bonus, you can try the factoring ones as bonus, okay? Or maybe even the systems of equations. I may just decide a few things are bonuses without telling you. So anyway, that is the practice final. And we did that all before the end of period 3. That's good. So that was a lot. If we have any questions, comments, concerns, if we want any specific types of problems for practice, if there's anything I can do to support you guys, I am here for that. But I am going to give us, I'm going to say, since we are now completed with the practice final, I'm going to give us about 10 minutes to go take a little break, bathroom, drink, whatever we need. And when we get back, you are free to go if you want, or you can try taking the final today. If you get it done, you have the whole rest of the week to make corrections. I would recommend getting some of it done today because it's only going to make the rest of your week easier. Even if you don't feel confident, you could get everything wrong. Guess what? At least you know that's not the answer. You can fix it. Okay? So, I'm going to end our video there. This is all the instruction for the rest of this class. Unless, of course, you have more questions for me, which in that case, I'm happy to answer them. I want to help you guys. But that's it.